Okay, this is what the standard's going to look like when we take it kind of close to after break, at least a week or two after break. Radicals is what it's called. Okay, find out what the fifth root of 18 equals. That's all you do is take 18 to the 1/5 power. You're trying to figure out what times what times what times what times what approximately is 18. Well, there's no perfect number as you're going to see here, so it's just rounded to 1.78. That's an odd root, so the plus or minus is not needed. Now, these next three, you can't have any decimals. Okay, you have to simplify it correctly, and you can't use decimals. Okay, so multiplication, there are 3 steps to multiply. You do not need a table. So first you multiply the coefficients, that's 6. Then we have a root, third root, and I take 80 times 128. 10,240. Okay, now I go look at my cubes list. Here's your perfect cubes number right here, the numbers in the cubed root. So you need to drop the 6 multiplied by 2 cubed roots or cube roots. Okay, so 10,240 divided by 1,000, that fails, decimal. 10,240 divided by 729 fails. 10,240 divided by 512. That's success. I divided by 512. I got 20. So I put 512 first and 20. Now, what's the cubed root of 512? I divided by it for a reason, because there's a number that what times what times what's 512? Well, it's 8. So the cubed root of 512 equals 8. Okay, now we find the product of 6 and 8, and that's 48, cubed root 20. Okay, now adding is a different ball game. You need this chart over here, and you take 3 cubed root of 10 and 2 cubed root of 80. Now, to simplify each one, there are 2 steps in the process. First, you drop your 3 coefficient, and then you make 2 cubed roots. Now, 10. I don't think 10 is divisible by anything except for 1. So guess what? This really can't be simplified, so circle that, and that means it's prime. Now, the other one. Okay, 80. 80 divides by 8, obviously. 80 divided by 8 is 10. The reason we divide by 8 is because the cubed root of 8 is equal to 2. So I find the product of the 2's, and that's 4 cubed root 10. Okay, now look at what we have. Now we have a common cubed root. It's cubed root over 10, and I add the coefficients 3 and 4, and that's 7. Okay, number 4, you're simplifying with variables, so we break it up. And then the cubed root of 250, I make a couple cubed roots here. Let's see what 250 divides by from my perfect cubes list. So 250 would not divide by 216. It does divide by 125. So 125, 250 divided by 125 is 2. So I put the 125 and the 2. You need to get rid of that cubed root 25 because that actually equals 5. Okay, now, with the letters, I just make 1 cubed root. Now, how many groups of 3 you get out of 7? You can get 2. You'd have 1 left. How many groups of 3 can you get out of 8? You can get 2 full groups with 2 left. Now, you make your cubed root. You put 5 outside and 2 inside. X squared outside, and there's an X left inside. Y second outside, and there's 2 Y's left inside. Remember to put that 3 there, so you're telling me it's a cubed root. Okay, solving equations. This is where it gets kind of tricky. It's a hard standard, it really is. It's That's why I wanted to start it before break. Okay, if I have just one x inside of a root, it's one answer. Okay, whenever x is enclosed within a mathematical structure, we want to use q. Okay, now there's really nothing I need to worry about here or here, so I need to eliminate the cubed root. Well, the opposite of cubed root is taking it to the power of 3. By the way, if we're using q, I'm going to set up this table. So that cancels, we get q. Now 2 to the 3 is just 8, and it's not a root. I just took it to the third power, so there's no plus or minus. So I'm going to cross that out, and it's just equal to 8. So I bring in 5x minus 4. So I plus 4, 5x equals 12, divide by 5, and that is 2.4. Okay, next problem, solving for x. Again, the x is enclosed in a structure. We would want to use q. So negative 2 square root of q plus 13 equals negative 11. So first I need to minus 13 out of there. So negative 2 multiplied by the square root of q equals negative 24. Now I cancel the multiplier by dividing. And the square root of q equals 12. By the way, we're using q, so I probably want the table. I might not do the other half, though. It's a square root, so we take both sides to the second power. And it's 144. Now, it's only positive 144. Okay, there's no root to it. Okay, 12 to the second. 12 to the second is 144. So we're going to put NO. So bring in 24x, divide by 24, and that's 6. Okay, now the next one. My x is to the power of 2, so there are 2 answers to this, I think. Okay, so let's talk about this. This is the only x I have. It's to the 2/3 power, so I solve it using like terms method. So we box it. There's no adding or subtracting, just divided by 2. That's 16. Now, how do I cancel out a power of 2/3? I would take it to the power of the reciprocal, so 3 over 2 power, 3 over 2 power. That cancels and we have x. Now here's what that means. It means 16 to the third power followed by a square root. 16 to the third power followed by a square root. What kind of root did I just say? I said a square root. So we need the plus or minus. So 16 to the power of 3 over 2, and that is 64. So my answers are 64 and negative 64. Okay, next one. This is a 5 up top here. So how many answers? The exponent's 5. And I would want to use the q because the x is inside of a structure. So I replace that with q to the 5 over 3 power minus 73 equals 70. Then we'll set this chart up over here. Maybe I'll need the other half, maybe I won't. So I add 73. So 170 plus 73 is 243. So it's 5 over 3, so I need to take it to the power of 3/5, and those cancel. So that's 3/5. I got to take this to 3/5. Now, you tell me what that means. It means 243 to the third power followed by a 5th root. 243 to the third power followed by a 5th root. Now, I said the word root. It's a 5th root, though, so no plus or minus is needed, so we put no. And I just take 243 to the power of 3/5. 27. So equals 27, and we just bring in x minus 5. That gives me my answer, 32. These are all garbage. Again, with that number on the bottom, that means a root. Okay, next one. X to the 6th power equals 140. It looks like kind of a simple equation. So I don't need to factor. That's the only kind of X I have. I don't need the Q. It's not in a structure. It's just like terms. Well, I don't really need to do anything except for the 6th power. So if it's the 6th power, we're going to do a 6th root. Okay, that cancels. Now it's a root and it's even, so plus minus is needed. So to find that, then I take 140 to the 1/6 power. That's 2.28. So 2.28 negative 2.28. Okay, now we're back to having a root, but when I have an X out and an X in, there's two answers. I mean, I don't see any powers, so one answer, but then there's another X out there, so there's two. Okay, now, if there's nothing outside of my root, it really makes no sense to bring in Q, okay? Or actually, I can, that's fine, so. So all you have is a square root, so we take it to the 2nd power. That'll give me Q. Now, how do I find X plus 5? You got to duplicate it off to the side. So X times X, X times 5, 5 times X, and 5 times 5. X squared, 5X, 5X, and 25, and that adds up to 10X. Okay, now X squared plus 10X plus 25, and then we bring back the 21X plus 1. Now I need to use factoring because I have this and this, so we got to move everything to one side. So I should get rid of the stuff over here. So minus 21X, and that would go with the 10X. That'd go with 25. So I've got X squared minus 11X plus 24 equals 0. Okay, GCF and T. GCF, don't have one. Positive 24, sum of 11, that's 3 and 8, and A equals 1. Okay, so I have minus 11 minus 8, and sum would mean they're both minus. X minus 3 equals 0, X minus 8 equals 0. So plus 3, I get 3. Plus 8, I get 8. Rationalizing, okay? Here's what you do to rationalize. Put that in parentheses and you have a plus, so you need to switch it to minus and write the same two things. So I FOIL 6 times 6. If you don't have a minus, you do something easier, but with these have minuses. So 36, negative 42i, positive 42i, and negative 49i squared. These cancel because they add up to 0, and when it's I, you replace it with negative 1, and then the product there is positive 49. Now we just add those together, and I get one single digit number answer, and that's 85. Okay, you see a plus, you need to switch it to minus. And with square roots, you want multipliers of 1. So I take 7 times 7. 7 times negative 1 square root 5. 1 square root of 5 times 7. And 1 square root of 5 times negative 1 square root of 5. So that's 49. Negative 7 square root 5. Positive 7 square root 5. Those cancel because they're opposites. And that's going to be negative 1, and then we got to times the 5s to get the square root of 25. Now the square root of 25 is a perfect square. It's equal to 5. Product of 5 and negative 1 is negative 5. Add those up, you get 44. Okay, then the almighty graph. y equals -2 times the cubed root of x plus 5 plus 8. Okay, first off, this plus 5 I'm going to take out. And now I only want to pick perfect cubes, so I start with 0 in the middle because I could go positive or negative because it is a cubed root, so we can put positives and negatives each in there. The domain includes positives and negatives. So what are your perfect cubes? 1, 8, and 27. Because here's your cubes. Okay, 1, 8, 27. And I could also do negatives. Now plug that in. So you go -2, parentheses 27, and then you need to make it a cubed root, you take it to the 1/3 power plus 8. That's 2. Now plug 8 in. So -2, parentheses 8 to the 1/3 power plus 8 gives me 4. Okay, and then what we're going to get is 6, 8, 10, 12, and 14. Okay, so 27, 2, go by 5s. 5, 10, 15. Oh, yeah, by the way, the plus 5, you need to cancel plus 5. You do minus 5 from all these. So it's going to be 22, 3, -4, -5, -6, -8 minus 5 is -13, and -32. Now cross all that out, because now you're ready to go. Because putting a 22 in, 22 plus 5 is 27, and 27 is a perfect cube. 3 plus 5 is 8, 8's a perfect cube. So 5, 10, 15, 20, 22, up 1, 2. Okay, 3, 4, 1, or 5. We're going by 5s. Okay, so 3's right here, and then 1, 2, 3, 4. -4, 6. I go left, and then 1, 2, 3, 4, 5, 6. -5, 8. 1, 2, 3, 4, 5, and then, or no, 5's right here. 1, 2, 3, 4, 5, 6, 7, 8. 6, -10, so 5 and 6. -10's way up here. Actually, hold on, I did that all wrong. I need to go by 5s on the x, I need to go by 2s on the y, so 22, 2. So 5, 10, 15, 20, 22, and then 2's right there. 3, 4, 3's right here, and then 2, 4. -4, 6, -4, and then 2, 4, 6. -5, 8, so -5's here. 2, 4, 6, 8. -6, 10, I go left 5, up 1, and then 2, 4, 6, 8, 10. -13, 12, I go 5, 10, and then 13, then 2, 4, 6, 8, 10, 12. And then -32 and 14. 5, 10, 15, 20, 25, 30, 32, and then 2, 4, 6, 8, 10, 12, 13, 10. 2, 4, 6, 8, 10, 12, 14. Okay. Make them in the order they were graphed. Okay. Okay, we need arrows coming off both ends because I go in both directions, the positives and the negatives.